Hi guys, I'm just going to give a quick explanation on how to find a rate of change given a graph or a set of data. So if you're given a set of data, your best bet is to graph it first. And if you're just given the graph and asked to find the rate of change over time, the thing to remember is that rate of change is the slope of the line that occurs between 2 points that are given to you. So I'm looking at the trout pond example, which is from lesson 1.2, rate of change. It's in the practice materials. It's like the last question. And so it actually asks for the rate of change around year 6. So our best bet is to actually figure out what the slope of the line is between years 5 and 7. And when we actually do that, we will find the rate of change, the average rate of change over the course around year 6. It'll be like the year preceding and the year following. So to do this on a graph, what we'd actually do is we'd mark the points that we're going to use as our reference, so 5 and 7, because it wants to know about 6, so we're just going to go around it. Because the thing is, if we just look at 6, there is no slope. This is a curved line. We can't really tell a slope, although it's straight-ish around this time. It's not really as accurate, and we can't use that 100% of the time. So we go a bit before and a bit after that particular moment. So now, let's just mark what these coordinates designate. So this is 7, and that's about, I don't know, let's say 370. So that point there is 7, 370. And this point over here is 5 and 200. So those are the 2 points. And we can do this graphically by just taking our ruler and drawing a line between the two. There is our line, which you can barely see because it's a dark blue line on a black line, that tells us about the average rate of change. The slope of this line actually tells us the average rate of change. So we can do this right on the graph. And I'll show you how to do it algebraically afterwards as well. But there it is. And if you remember, slope is found by taking rise and divide it by run. That's slope. And slope is the rate of change. So the run is going to be, looks like 2 boxes. The rise is going to be 50, 100, 150 plus another 20 or so, so it's 170. And so our rate of change can be found as 170 divided by 2, which is 85. And then we just take the population, so fish per run year. So that's trout per year. Now we can do this algebraically as well, and we would just take these 2 points that we circled over here, and I'll just transfer them onto another sheet of paper right over here. And all we do is we would say the rate of change is equal to this little triangle here means change in y over the change in x, otherwise known as y2 minus y1 over x2 minus x1. Remember that? That's the equation for slope. And if you remember, our 2 points were, I don't remember what our 2 points were. Our 2 points were 7, 370, and 5, 200. So let's make this one x1 at y1, this one here x2, y2, and now we'll just pop them into the formula, which is going to be 370 subtract 200 over 7 subtract 5. It's really important that if you're labeling these points x2, y2, and x1, y1, don't mix them up. Don't have something like x1, y2, and x2, y1. That's really going to screw you up. One set of points are the 1s, the other set of points are the 2s. Plug them all into the formula in the correct order, so 2 minus 1, 2 minus 1. And it doesn't matter which one's the 1s, which one's the 2s, as long as you remain consistent once you've decided. Okay, so now continuing along with the calculation, we end up with 170 divided by 2. This should look familiar because it's the same thing we had on the previous page, which is 85. And again, we insert our units, trout per year. Okay, and that's average rate of change in a nutshell. Hope this helps.